Hey guys, welcome back to my channel. This is Miss Perkins speaking, as if anybody else would be on this channel, but whatever. We are back at it again. This time we are talking about parallel circuits. This question comes from Physics Aviary. And for the parallel circuits, they want you to determine the total current in this circuit. So actually not that bad, except this is a beast of a problem if you are new to parallel circuits, okay? So I'm going to walk y'all through the way that I like to solve these problems. If you have another method that you find better and works, please drop it in the comments below. Maybe it'll help some of my students out. Thank you very much. Also, like and subscribe. I think that's the thing I'm going to start saying now, so please like and subscribe. I don't know why. That's just something I hear all YouTubers say. So students, do the same. Love you, mean it. All right, so step one. Whenever we're solving any of these problems, we always start by solving for our total resistance. But whenever we solve for parallel circuits, we do it a little bit differently. We have to take the reciprocal of each of our resistances and then add them together. Okay, so for this problem, reciprocal just meaning 1 over whatever your resistance is, okay? So 1 over 240 ohms plus 1 over 150 ohms plus 1 over 710 ohms, okay? And right now you're thinking, Miss Perkins, this is the worst part, isn't it? Yes, babies, it sure is. So with these problems, these do not have nice, easy, simple common denominators. So remember, what I like to do is I like to take all of these numbers and multiply them in order to find a new common denominator, because if you multiply all of them together, you will always get a common denominator that they all go into, okay? If you have a simpler way of doing this, drop it in the comments, because that's what I'd be talking about, because this is the best way I know how to do it. And we do love new advice, because this common denominator is 25,560,000. Okay. Okay. And to find your numerator, what I do is I take the denominator I just found and I divide it by the original denominator. Okay, so if my original denominator was 240, I divide 25,560,000 by 240. And my numerator is going to be 106,500. Now, because all of these numbers that were in the original denominators, they all should go into this common denominator perfectly. So if you end up with a decimal in your numerator, something went wrong somewhere. So that's an easy way you can check your work. Okay, so then for my second number, divided by 150, I'm getting 170,400. And for my very last one, I divide by 710, and I'm getting 36,000. Okay, so now I add these puppies together. 36,000 plus 170,400 plus 106,500. I get 312,900 over my ridiculous denominator. and I need to flip both sides and divide. Okay, so I end up doing 25,560,000 divided by 312,900. And I'm getting 81 point, let's round to 69 ohms. And that is my total resistance. Okay, so that was step one. Oh. I love that. Okay. But luckily, they don't do us in like they did with the series circuit and make us do 4 steps. Like, this honestly is 4 steps all by itself, but the next step is just to find your total current because that's what they wanted. Okay, so total current is still equal to your voltage divided by your total resistance. Don't have to do anything crazy to get our voltage. It's right over there. And we're dividing that by 81. So we should get something in the ballpark of 1 divided by 9. Right? 9 times 9 is 81. Yeah, okay. So I do 9 divided by 81.69. And I'm getting 0.11 amps for my total current. Okay, and that should do it. Please like and subscribe, especially if you're my student, because if you want help and you want to know when that help is coming, just subscribe to my channel and I'll take care of you. Miss you, students, and yeah, goodbye. I hope you're living your best life.